Hello and welcome to Math 251 Calculus 1 here at Cañada College. My name is Lapuz and I'm the instructor for the course. In this video we will take a quick look at section 1.5 where we study logs and exponents. Exponential functions are functions that are different from the power functions because the base is the constant and the exponent is the variable. So with power functions, our base was the variable and our exponent was constant, but now we're going to switch it around and we have an exponential function. So with this exponential function, we're going to plot some points and graph it and see what happens for different values of x. And we're going to see that our domain is going to be all real numbers because we can put any value of x that we want. But our range, interestingly enough, is just going to be just the positive numbers. And so with that, we're going to remind ourselves some of the basic laws of exponents. Things where we multiply two expressions with the same base, we add the exponents. To divide, we subtract the exponents, etc. And so I hope that these rules are all familiar and we're all comfortable with. We're also going to get introduced to our very special number e. E is a number that's about 2.718, and it becomes a special number for us because we'll see in calculus, or when we start doing derivatives, that there is a special property involved here. So this is a very special number that's studied in calculus. After the exponents, you'll see that the exponential function is a one-to-one function, so it would be natural to find its inverse by reflecting about the y equals x line. So when we do that for our e to the x function, we're going to get our ln x function, a natural log function. And so with this natural log function, we see that for this exponential, it's the inverse of the exponential function. So our other exponential functions with a different basis, like 2 squared or 10 squared, or I'm sorry, 2 to the x or 10 to the x, they also have our logs, their corresponding inverse functions with logarithms. And so here's where we get to define our logarithms. And as we define logarithms, they have special properties. When you take the log of things that you're multiplying, you end up adding the logs of each of them. And when you're dividing an expression inside a log, you're subtracting. Now, I want you to think back to the exponential properties and see how these are related. We have a multiplication that becomes some sort of addition and a division that becomes some sort of a subtraction. There are properties like that that's associated with exponential functions, and they are not a coincidence. And similarly here, when you take the power of r, or power of a to the r, in our last property here, the r becomes a coefficient, you're multiplying it. So raising to a power and multiplying, that too looks like it's one of those properties for exponents. And after that, we're going to study these things called hyperbolic functions. We're just going to gloss over them. You might have some homework problems associated with hyperbolic functions, but I'm not going to put them on the test. But it is a very important function that's studied a lot in physics and engineering. And what they are is that they really, they start off looking like trig functions, but they're trig functions that's really defined by exponential functions. Hyperbolic cosine, for example, is e to the x plus e to the negative x divided by 2, and hyperbolic sine is e to the x minus e to the negative x divided by 2. So we say, instead of saying hyperbolic cosine because it's so long, we tend to shorten it by saying cosh. And the sine hyperbolic, we tend to say sinh. I know it does not spell the word cinch, but that's how we call it. And the rest of the hyperbolic functions we just kind of say it all out loud: tangent hyperbolic or hyperbolic tangent, etc. So they are defined similarly like trig functions, but then they all go back to the signs, or the sinh and cosh, and it's defined by that. So it's all defined by exponential functions. And with that, we're going to have some basic identities. The cosh turns out to be an even function, just like the cosine is, and so is the sinh, just like the sine. It's an odd function. And then you have the addition of these things, and some similar. Number 5, for example, is similar to our Pythagorean identity for trig, except it's a minus sign instead of a plus sign. So we have to just be careful with them. And you can rederive any of these identities by going back to the definition using the exponential functions. Finally, we're going to need to find the inverse of these hyperbolic functions as well. And so they have kind of, I was going to say, nice compact forms. They might not look very nice, but they are compact, and they're about as nice as we can get them to look like. And so they are inverse hyperbolic functions. Okay, you should also study the graphs of these things, because the graphs of these things are kind of important and interesting as well. Okay, so this is our quick overview of section 1.5. This is the end of chapter 1. And so I'm hoping that all of this is a review, except maybe the hyperbolic functions. But this will get us going. Once we know all these functions, these basics of these functions, then we can start doing the calculus on them. All right, good luck.